Hey guys, this is Ian from TechTechPotato, and today we're going to go through Intel's latest announcements regarding Ponte Vecchio and Sapphire with HBM, which they've happily called Max Series. Max Series GPU for Ponte Vecchio, Max Series Xeon for Sapphire Rapids with HBM. But that's not all. Guest starring today is Patrick Kennedy from Surf the Home. Say hi, Patrick.
Hey guys!
If you need a RISC-V core for your solution, head on over to Sci5. They've got a wide range of vector performance cores for your solution. This is so big, Sci5 is one of the players that helps develop the standards for the RISC-V architecture. It's so big, even Intel has skin in this game. Some of the leading AI companies are using Sci5's cores in their next generation products because they want something that's different to what's out on the market, slightly customized for their use case, and something with enough performance to drive home their solution. So if you're interested, head on over to sci5.com today. So hey Patrick, how's it going?
Amazing. Welcome to the STH studio.
This is pretty cool. I've only seen it from behind the camera.
Yeah.
But today, Max CPU, GPU.
Max CPU, GPU. Let's do it.
You were at Supercomputing this year.
I was. I just came back, and Ian actually just arrived just after I got back from Supercomputing the day after. So we're doing this pretty close to Supercomputing, but we got a lot of big announcements.
Yeah. So let's start off with this Max CPU, Sapphire Rapids with HBM. You managed to pick one up.
I have.
With it.
So I managed to pick one up, I think it was like March of this last year, March, April this year, something like that, and did a couple photos, put them on Twitter and on the main site, and then I think that was really just kind of cool, just getting to see the fact that you have the HBM package, and so you have the little HBM packages around the main Sapphire Rapids high core count really package, and I thought that was just really cool.
I mean, the Max CPU is a result of this trend whereby we're getting so many cores now on CPUs, they need the memory bandwidth for the types of workloads they're going to do. I mean, we've got Genoa, which is now out with 12 channels of memory. We've got Sapphire Rapids coming, the base with 8 channels of memory. This HBM increases that memory bandwidth per core, so it's going to find some very niche workloads that it's going to go into, but it's going to be what those workloads definitely need.
Yeah, and I think that the memory side of the new CPUs is a little different, right? Because not only do we go from having 8 channels, I guess, on Sapphire, but then 12 channels on Genoa, but we've also moved from DDR4 to DDR5, so we get a nice memory bandwidth bump from that, and also some new features. But then the flip side to it is a lot of these larger workloads, they're saying, hey, that memory and those memory channels, that's just too slow to go off into DDR4, DDR5. We need data closer to the cores.
Yep.
So we have things like the Milan X, which if you want, I can go pull one out, but show you the Milan X, and that really has the higher cache, so level 3 cache. Genoa X will have the higher level 3 cache, and then Sapphire Rapids HBM, of course, that's the one where you're going to have the 64 gigabytes of HBM on board, which is super cool.
So 4 stacks of HBM 2E, totaling about 1 terabyte second of memory bandwidth, about 1 gigabyte of HBM per core. So Sapphire Rapids with HBM will top out at 56 cores, though the regular Sapphire Rapids we know already will top out at 60 cores. So there is some trade-off there. But what's key here, I think, is that Intel, initially with Xeon Phi and the MC DRAM, and then with Optane, has been playing around with this sort of tiered memory strategy. So they've been able to essentially sort out the software stack, the firmware, so they can make that this HBM is either additive to DRAM or cached to DRAM or bypassed fully. And one interesting thing here is you can boot these new Max CPUs without any DRAM at all.
Yeah.
So we're going to see some really hyper-dense installations that don't need the expense of DDR5. I mean, we're both seeing, when we talk to these OEMs, the added expense of DDR5 is a concern that some of these customers have.
Yeah, and I think it's two things. So it's the cost of DDR5, which of course costs more per gigabyte than DDR4. But the other thing is also when you look at the power consumption of a system, you figure a DDR5 DIMM is somewhere around 5 watts-ish. And so if you were to remove the DDR from a system and you had 8 DIMMs because you want to fill your memory channels, each socket then has about 40 watts worth of just the memory. Plus you have the CPU that right now is topping out at, I don't know, actually, can we say how much they topped out? I don't think they've actually said that.
Sapphire Rapids is going to be north of 300.
Yes, let's say north of 300. So that extra DDR5 memory, that really is adding, say, more than 10% to the total power consumption of a socket.
Yeah, but also memory controller use. I'm pretty sure the memory controllers for those systems also use more power. So HBM could use slightly less.
So HBM will use more for the package, and that's one of the reasons that we're seeing, things like these are only 56 core max parts right now, just because they're running into TDP limits. Because the HBM stacks, they may look a lot smaller than DDR5 DIMMs, but they actually use quite a bit of power. So
yeah, I mean, so for this launch, we don't have a full SKU stack. All they've said is all the SKUs with HBM, they will all have 64 gigabytes. So there's going to be no tiering down with only 3 stacks or 2 stacks. Everything's going to have 4 stacks. We expect to see core count reductions. I highly expect there to be sort of like a highly optimized 32 core count version with HBM at some point. Don't know that yet. But
I've been campaigning for certain SKUs. I'll tell you that.
Yeah,
I've seen what Intel's putting out, and I've been campaigning for a little bit of edits to that. So hopefully.
But Intel has been putting out some numbers, and we'll throw out some slides. For example, this one here, improved performance per watt, 70%, lower power than Milan X cluster for the same performance. Again, you can play a lot around with these numbers depending on how big your data set is. If you're going outside of the cache, you're instantly using more power to DRAM. So if you have a data set that just goes out of it, then having that HBM is definitely going to be more power efficient. And then comparing that to what Intel says is real-world workloads here. We've got things like weather forecasting, black shoals, lamps, folding, ANSYS Fluent. Intel's saying anywhere from a 1.2x to a 4.8x speed up against Milan X.
Well, I think the 4.8x, let's be a little fair, that's Stream Triad, I think, and the Stream Triad numbers, that's like literally a memory bandwidth benchmark. So the fact that you get like 4.8x, to me, at least, is not overly exciting because, I mean, that's literally testing how fast your memory is, and that's not really like how fast my application is, right? So I kind of see that as a 4.8 as a little bit reaching, but it's fair, but it's a well-known number in the industry. But I just kind of think that one's a little bit reaching. But the flip side to that is that they were also comparing that against Milan X. And so if you think about the next generation, we know that there is going to be a Genoa X. And so when you start talking about having, more performance per core, plus having more just more cores, and also having more cache on that socket, right? So because AMD will be over 1.1 gigabytes per socket of level 3 cache at that point. So I just do think that that's going to be an interesting from a sizing standpoint, like you said, because if you go over that one gigabyte of problem set, right? I mean, then all of a sudden, then maybe the HBM is way better up until 64 gigs. Then maybe you have such a giant random data set that maybe none of these things really help you. So it's kind of just interesting to think about how that's going to play out.
Actually, just thinking, so one of the tests that I usually do is memory latency versus depth. That currently tops out at about 2 gigabytes, just in order to encompass everything up to Milan X up to that point. I'm now going to have to refactor that to 128 gigs just to hit into the DRAM to get that extra lift. So, and one of the angles with HBM here is that you can replace multiple Intel Ice Lake dual socket systems with DRAM-less max CPU systems. The example they've given here is AccuSolve, which is a fluid and thermal simulation from Altair, going from 4 nodes to 1 node, reducing your power by 43%. The whole thing, every generation, is power consumption, TCO, the fact that you have to run and support these. If you can support fewer nodes, or maybe you just get the same number of nodes and do more. So we don't have pricing yet, so we can't really talk about TCO.
I also think that at the high end of the Max series, the entire system power is not going to be 700. They might actually be looking at more as the TDP of the chips there rather than the total system. Just throw that out there.
Well, it's I don't think this specifies whether it's 2p versus 1p or not. So, yeah, okay, yeah. So, I'm just trying to think. We've already tested Genoa, for example, which is the next generation stuff. That's 96 cores per chip. And a dual socket system with memory and really nothing else peaks out about 1,000 watts.
Yeah, so we got it up to, I think, 1.2 kilowatts. So it's somewhere in that 1 to 1.2 kilowatt range for a dual 96 core. Really not a whole lot else in there, right? That's like one pretty high-speed NIC, maybe two.
Yeah.
And then memory channels filled, 1 or 2 SSDs. You're really talking in that. You can kind of budget that kind of system, right? Really that kind of bare bones, just really CPU memory system to be in that 1 to 1.2 kilowatt range.
One of the things I'm finding looking into, these new generation parts that are pushing the higher TDPs, the standard rack is only rated for what? 12 kilowatts, 24 kilowatts?
Yeah, so it depends on what it is. So in the North American market, really the standard rack for just generations has been the 208 volt 30 amp rack. And so that gives you just shy of, say, 5 kilowatts continuous.
Yeah.
And so, that's really, that's kind of really the starting point where a lot of North American racks are. So, there are definitely a lot of places that have higher end racks. And especially these days, you're seeing a lot of places push to 10, 14, 30, 40 kilowatts. But, there are still a huge number in terms of the install base of just racks out there that are stuck at like that, more or less 5 kilowatts max.
So in that instance, even though these chips are a density play, they're consuming so much power that you can only put so many systems in a rack anyway. So that...
Yeah, and that has some impacts also, just because one of the things that you see in modern servers is that a huge portion of the power consumption is actually just from air cooling, especially if you have an air-cooled server. You have, say, 2U fans. You'll see that typically you're being the 15 to 20 watt, depending on the type of server, will go to cooling. When you get to the GPU systems, often 20% is a lot of GPU, like high-end GPU systems like the A100 systems and even the V100 systems did this and all that. You really see that the 20% is actually very reasonable for a total system power draw due to the fans. And so by using 2U versus 1U form factors, if you're not going to have as densely, if you're not putting a 1U server just farm in there, you actually do get a little bit of efficiency back, like a couple % back by going to 2U form factor versus 1U. So you gain a little bit back because it's not as dense, but on the other hand, I don't think we're going to see people put like 4U dual socket servers just to get bigger coolers and fans.
Yeah. It's, again, to talk about the Genoa system we've both tested again, that's got 6 massive fans and they each consume about 40 watts at full load. So out of a 1,000 watt system, if you're going full bore, that's 200 watts of just cooling. So it's important to note here. With I'm looking forward to testing this new Max CPU just because I was always a big fan of Xeon Phi with the extra MCD RAM. So obviously when Milan X came around, it was like, hey, this is cool, but it's probably still not enough cache for a lot of people. I've noticed people in the HPC crowd going, oh, this is going to be amazing. The fact that you can also have the DRAM-less situation, that's going to be interesting. Funnily enough, during the briefing, I asked if it supported Crow's Pass, the now defunct Optane platform.
Well, it will.
Well, sorry. They said yes, it would.
Yeah. So there will be a Optane generation that is released with the new generation of Sapphire Rapids parts. They pretty much produced what they thought would be enough for this generation.
Yep.
It's just the go-forward products that are going to be not going to be around.
Yeah.
So.
But I want to try that as well because then you can have HBM with Crow's Pass and DDR5.
Yeah.
And so before you even hit NVMe storage, you already got 5 stages of memory and caching. And so we'll see how that plays out.
Yeah, that would be an interesting setup, especially if you could run it in memory mode. Or,
Yeah.
Can I tell a fun story?
Go on.
So when he's talking about Xeon Phi, the Knight's Landing parts,
Yeah.
I remember you and I both got systems. My system had to go back and went to Linus at Linus Tech Tips. But I think you still have yours,
I still have mine, yep. Yeah.
So, and one of the really cool things, by the way, about that system, and it's actually very similar to what Sapphire Rapids HBM has. Sorry, I need to say the Xeon
Max
or CPU Max.
Yep.
Right. But what both of these things had, and it's actually very similar, is although the type of memory is a little different, the idea was that you have on-package memory. That on-package memory is significantly faster. You can also have the additional DIMMs for additional capacity, or you could run it DRAM-less, which you could do on Xeon Phi as well. And the three modes that you have, being able to run DRAM-less with just the on-package memory, running as separate memory pools, so you have a faster, local HBM or MCDRAM pool plus DDR pool, that mode, or having caching. Those are actually the same as they had in Xeon Phi. And one of the coolest things I think about that is just the fact that as we go through these numbers, something to remember is that there are a lot of workloads that if you just put this in caching mode, the caching mode performance, the uplift that you get, can actually be quite significant, and you don't have to do anything. You literally just turn it onto caching mode, and a certain portion of your, of your memory access all of a sudden gets to HBM, and Intel's memory controllers do that. So when you're talking about Optane, that is exactly, by the way, how Optane in memory mode works. You have DRAM, which is your cache, because that's the faster media in that case, and then you have your slower Optane media, and that's kind of the whole caching idea as well. So Intel, by the way, has been doing this for years. It's just we're seeing the on-package memory again.
No, totally get it. And if you really wanted, at least with Optane, you could make that look like a separate drive, but with speeds of essentially DRAM. Same thing with Xeon Phi, make it look like a drive, and then it just becomes like that super uber fast scratch pad if you still want main memory to act like it is.
And with Optane, you can actually do another mode, which is fun, which you can do mixed mode, and you can have a portion of it which is in memory mode and a portion of it which is your fast drive.
Xeon Phi could as well, so... Let's see if Intel enables this on Macs.
Yeah, I'm kind of excited on that too,
Because then you could have 32 gigs cache and 32 gigs accessible as storage. Interesting. So that's the Max CPU. Now we go to Max GPU, or Ponte Vecchio, this 47-tile monster that Raja keeps flashing about.
It's very cool.
Again, you saw some at Supercomputing. You saw the PCIe card.
Yep.
We've got a picture of that. I'll show that on the video. So that's the Max GPU 1100.
Yep. So PCIe is Max 1100,
that goes up to 300 watts. So that's just so you can just put it in your system.
Yeah. And there's also the important thing that they're doing as well is they do have a GPU to GPU link, so an XE link that will cross the different cards up to 4 cards. That, if you're wondering, like, why can't they do 8 cards or something like that on these boards? Well, usually you'd need a switch for that, especially in these topologies. But the other thing is, in a lot of servers, even those 4 are a lot, because we had things like the Dell R750XA, for example. We did a whole bunch of other 2U multi-GPU systems, and in a 2U form factor, you can only stack 2 high anyway. So even having 4 is a lot for common 2U servers. Yeah,
and a one socket to 4 CPUs or a 2 socket to 4 CPUs is a very common configuration in this thing. The only time where you essentially get the 8 is a 2 to 8, but even Aurora is 2 to 6. Right. So getting that 1 to 4 is good for them. But so Ponte Vecchio, we've kind of covered it a lot up to this point.
I feel like,
we've got some official numbers. So 128 XE HPC cores, 52 teraflops of FP64 compute, which is, funnily enough, less than MI250X, but they're kind of going into slightly different markets. It's so some of this is built towards also AI, so it has also the AI features. Rambo cache, I mean, Intel's putting a lot of cache on this thing, and they're talking about all the memory bandwidth to all the different cache levels. We're talking terabytes per second. And again, HBM2E seems like this is Intel's new ingredient that it's wanting to pepper into places.
Yeah, and I think the other thing that Intel is really doing, and this is a subtle thing on the slides that you're probably seeing right now on screen, but one of the really interesting things that Intel is setting up is the ability to really feed their cores. So Intel and NVIDIA, their criticism of the MI250X, which, by the way, did an awesome job and took a lot of spots on the top 500, by the way. But the common criticism of the MI250X is that when you look at raw compute like LinPack, cool, it does really well. when you start looking at things like HPCG and all those, like the other benchmarks that really focus on data movement and are supposed to be more real world workloads for modern times, what you typically find there is that sometimes the MI250X gets starved.
Yeah, the thing about HPC, it's all about feeding the beast, right?
Yeah.
Very common phrase in this industry. So being able to put your data into memory and then feed it into your execution cores. If you've got I remember when I was programming GPUs, it's all about flops per byte. Bytes being how much data you can transfer, and flops just being how much compute you do on the same data. So if you have a loop, a very small loop, but you loop over it 1 billion times, you get a lot of flops per byte. But because things like finite element simulation requires a lot of data movement, AI requires a lot of data movement. There's that trade-off, and what the HBM2E is meant to be doing, and all this caching is on the Max CPU. I keep on calling it Ponte Vecchio. That's all geared towards that. So we're going to see, it's been in this industry for a while. People have said, well, the massive supercomputers are just LinPack chasing. They're not actual real-world chasing. But as you say, AMD's had a strong presence with the Cray Shasta system. I think it's 7 of the top 10.
Yeah, and also, I mean, so it's the same platform that Aurora will use. Just they'll use the Intel version of that.
Yeah.
So it's the same HPE Cray platform, just a little different. But also, just as a point here, which is important, is the fact that the MI250X was basically two top 500 lists earlier in its debut versus what we'll probably see. My guess is we're going to get Ponte Vecchio at ISC, so for the June-ish top 500 list. So if that's the case, AMD was a full year ahead, right? So it's kind of, you're looking at, in some ways, different generations of products. So just being clear there.
Yeah. So we've gone over the GPU 100. This is PCIe card, up to 300 watts. This will actually top out at 48 gigs of HBM2E. But then we also have the OAM modules, which is what we commonly see things like the H100, A100 in.
Well, the H100, A100 are SXM modules. So
right.
It is that type of form factor, but this is the one where Facebook said, hey, we don't want to be locked into a proprietary NVIDIA form factor, so we're going to make OAM. But you do see things like, for example, Habana, right? They have their accelerators in that. You also see like other companies have, I don't know if we're allowed to talk about those companies, but there are other companies that actually do have their accelerators in OAM. So it's going to be something that I think as an industry we're going to find. And the MI250X, by the way, is an OAM module. So the the OAM module is Open Compute Project. There's a universal baseboard which has all the interconnect between the 8 different modules and also the external links. And so I think that that's a form factor that Intel is adopting because that's kind of being seen as a more open form factor.
And the ability of this form factor is you're no longer limited to PCIe thermal limits. So this is now where we're getting the 450, the 600 watt, which is actually the 2 versions of the OAM module of Max GPU. I think back in the day when they initially announced the Aurora with Ponte Vecchio, I predicted about 560. So 600. I'm just saying, I had a good guess. So two versions of this OAM module. You've got the 96 gigabyte HBM2E version and the 128. They're called the 1350 and the 1550. 112 cores versus 128 cores, 450 watts versus 600 watts. No idea on pricing. But typically people just don't buy a single OAM module. You buy it in essentially a blade of 4. And because of the power, these are obviously going to be liquid cooled pretty much in every situation.
Well, you can cool 450 watts. That's not crazy to cool, especially in like a 4 config.
Yeah.
So we've seen that a couple times with the NVIDIA GPUs. When you start getting to 600 watts, that's another challenge though, because at 600 watts, people start looking at that like 20% that you need to cool in terms of just pushing airflow through it. Then they say, hey, that starts to make the case for liquid cooling. So I think that we are going to see a lot more OAM modules that are liquid cooled, and especially the OAM spec. We're talking about 600 watt GPUs today, but we've already seen demos at the Open Compute Summit a couple weeks ago where the OAM modules, they have like liquid cooling setups for like, oh, we know that there's 1 kilowatt accelerators in the nearby horizon.
Yep.
So here's our product for cooling that right now.
Yep.
And you're like, oh, okay, well they've already thought about 1 kilowatts per thing, because they're literally showing here's how you cool it and put it in a system, right? So
it's I mean, I did a video sometime last year, I think, about research done by TSMC where they were cooling 2.6 kilowatt, dummy loads. Mm-hmm. But it's clear that the technology is being done to be able to get that far. That used some sort of grooved silicon hat, and it was direct die cooling. We're not there yet with these. That's going to be a bit more complex with tiles as well, because all the tiles have to be the same height. So we'll have to see how that goes.
Well, and these GPUs, by the way, are actually different than what you typically would see on like a lot of the NVIDIA GPUs, especially the older NVIDIA GPUs. I don't remember what the H100 looks like, but I've held an H100, but if you look at like the old SXM packages, when I did the video on the P100, the Pascal generation, so they actually just had like, here's your package, here's the dies, go put your heatsink on top of it. And if I have a very expensive, like, a couple $100 screwdriver, because they had a very, very specific torque specs for that. The ones that we've seen for Ponte Vecchio actually have a heat spreader on top. So that is a difference that Intel is doing that I think is actually good from a packaging, and it's first gen, like, hey, let's not go crack all these things as easily, because there's definitely a lot of P100 V100s I remember people talking about were definitely got torqued a little too hard and broke because of that. So
especially when you're talking about 25K a chip. We have no pricing on the Max GPUs, but with all those tiles, with all the leading edge process nodes, with all the packaging, it's going to cost something a lot. I don't know, we'll see. So aside from the Max CPU, this sort of first generation, the 1000 series, I can only assume the next generation is going to be called 2000. But we already know the code name for that generation, which is Rialto Bridge. So one of the disclosures at Supercomputing was Rialto Bridge is going to look somewhat similar, have more cores, and go up to 800 watts. So as you were saying, the 1 kilowatt coolers, they're all ready to go. And I kind of expect it just to be a sort of slot-in replacement type situation, sort of a natural progression rather than evolution. I mean, Intel has to amortize some costs somewhere. Right?
Yeah, so I think Rialto, that's still going to use the UBBs, right? So you're still going to have the same baseboards, my guess is. And then you also see that Rialto was always discussed as, that's a kind of like when you had the old TikTok, right? That's kind of the more minor stepping, just because that's the one that's, I should say minor step, because it's kind of chill, right? But it's just a more minor step, right? It's really kind of seen as one of those technologies that's a little bit faster than the current generation. There's some enhancements in terms of being able to manufacture it and all that kind of stuff, but it's not necessarily like it's not the Falcon Shores of this.
Speaking of Falcon Shores, Max CPU, GPU part over. Falcon Shores part begins. So after Rialto Bridge, after what we presume is the next Rapids plus HBM, Intel is showcasing Falcon Shores. Well, they've already announced that it's a product that's coming. It's going to be mixing bits of CPU, some bits of GPU, some bits of AI, maybe. This whole XPU strategy of Intel, being able to use multiple chiplets in sort of kind of any configuration. Falcon Shores, essentially next-gen flexible architecture, they're calling it. All they're saying in the notes here is compute density in an x86 socket, so it's going to be socket compatible with the CPUs. Going to have high memory capacity and bandwidth, performance per watt, and also if a customer has some custom silicon they want to put in, think maybe a cloud provider has an accelerator they want to use, as long as it's in the right chiplet format for them to use, this is what's going to go into Falcon Shores. So I'm going to be interested here. I have some strong thoughts about chiplet ecosystem and how I don't think it's necessarily a viable solution, but that's perhaps for another video. But yeah, Falcon Shores, I guess 2024, 25.
Yeah, hopefully.
Yeah.
But I also think that what is really interesting about Falcon Shores is Intel calls it their XPU, And if you look at what both AMD and NVIDIA are doing, right, you have Grace Hopper, which is a co-packaged, although it's not necessarily this level of integration. It's really kind of two different chips that are packaged together. But Grace Hopper really is putting their ARM cores, so CPU resources with high-speed memory and also the GPU compute. You look on the AMD side with the MI300, that is also going to be looking at high-speed memory, high-speed GPU cores, and then also some compute cores, and co-packaging that all together, because that data movement off of the package is so costly. We talked about the 5 watt DDR5 DIMMs, but that data movement is so costly that co-packaging all the stuff together is actually seen as a way to vastly reduce the power consumption. And a lot of these supercomputers are really power limited, right? And so when you start getting power limited, like how much can we get out of like 20 megawatts or something, then that's when you really start looking at like, hey, if we can reduce power by 30, 40, 50%, that gives us a lot more compute performance potentially, just because we can put more accelerators in there.
You want to keep as much of that on die. So the interesting thing about the MI300 is it's kind of like an APU, CPU, GPU, accelerator all on one. So I'm going to call MI300 an APU, but this year, Intel's focus at supercomputing wasn't Aurora entering the top 500, as we'd all hoped, but it is the announcement of Max CPU and Max GPU, the stuff that's coming through 2023. We're fully hoping that Intel at least samples us the Max CPU. So it's going to be socket compatible with Sapphire Rapids CPU. Where's yours, Patrick?
Oh, there you go.
Well,
Sapphire Rapids.
This is the kind of fake one in Lucite they gave us in the reviewers workshop. But it's going to be, so the Sapphire Rapids with HBM, it's going to have a couple of wings on top and bottom. You may remember if you ever play with Xeon Phi with Omnipath Fabric, the F SKUs, they had a little thing that came out the top that you could connect.
And Xeons had that as well. The F series Xeons, we had Xeon Gold 6138Fs, I think.
So it's going to be essentially one package, two package sizes for one socket. So we can't wait to get them in. GPUs, we'll see. Then these companies don't necessarily like to hand out the high-end compute GPUs for review. Patrick will get one. But looking forward to it. And stay tuned. And don't forget to like and subscribe to Patrick. Smash that bell.
Definitely.